I request he is always there. So that matters a lot. So he suggested this, and I have included by coding his book to my PhD thesis, 2 examples, and many people they use the same examples. You have to cite, that is mandatory, is not your result. If your result, fine. If is not your result, at least you regard the person that this result belongs to this. This samosa is very good from this shop. So at least you should put a regard. So nothing wrong, and that shows your wisdom. So I have 2 examples, and somebody was asking from your side only, might be to Professor Virendra or Professor Veermani, I think, that which condition is weaker. Something they are talking about. They are independent. I am showing you the examples. This is the example, and these 2 examples I borrowed from the book of Professor B.K. Lahiri. Now he is no more. His son also retired from, I think, from Roorkee, sir, or somewhere, some university. So these are the 2 examples you can see, and you can find that the first example and then the second example. Second example, Banach, not Kannan. First example, Kannan, not Banach. So superficially we have not to learn such things. Go into the depth. What the mapping has made the difference between these 2 inequalities? Why the first one is right for Kannan, second one is not right for Kannan? Why the first one is right for Banach or second one is not right for the Banach? What happened with the mapping T? So that we learn later on, or we blindly presume that because of the continuity issue. We have to work out, even we know many things, we have to work out whether the term continuity exists or not. That is the beauty, that the first one, Banach, as I said, the inequality itself provide you the continuity of the function. The second one not allowing you to pick the continuity, even it has a fixed point. And sir, now these days there are the data scientists, they are working on Kannan, not Banach. Yes, they are working on Kannan, because in data science what I say, see, I have the mathematical ideas, and in mathematics when we say real, do we find any gap between, how do we differentiate between a discrete point and the discrete and this real? I used to give a simple example. You take polythene, pour water, the water won't come out. I say this is real, and you pour water even in any of paper or something, and maybe initially may not be coming out, but after some time, yes, even our skin is porous because it has holes. So you can check the discrete and real in this manner. So when we talk about the real, what exactly the philosophy come into our mind immediately? We find that every space is filled with some dots, right? Some point, some numbers. And one more thing is, when we look into the Cantor's intersection, Cantor's theory is enough to say that yes, how many numbers we don't know, how many powers we have to put, infinity to the power. So like that, the numbers are, the real line is full of numbers. But what about the data? Data never been finite. This is the reality of the world. This is the reality. How we can say that the population is infinite? We talk about infinity, but we never realize infinity. In the real life scenario, we only realize finite. Possibly, this finite also, because of the huge numbers, we are unable to count because of the population. So in data, during our period, means our lifetime, we may not count, but data can't be infinity. Not limited, I can say. Not limited doesn't mean that is infinite. So when the data is infinite, then how you are going to draw a continuous curve? So using such data, we are compressing the data or follow the data that we can draw a continuous curve. Means we are pressurizing, and we have the ability to change the nature of the data. This is what the data scientists used to do, because we have the limited thinking. We can't go beyond that in a limited time. But because of the student of mathematics, we are very easily can say that this function is continuous for all values of x. How? The question is, for all values of, you realize the function is continuous for all values of x? Because our study says, that is also a data. Our study says that these are the functions, they are continuous for all values of x. But you try to realize them, you try to visualize them, and that becomes passion, and your research becomes extraordinary, no doubt about it, and you do wonders. And this is only the time when you are below 30, 35, you can do wonders. And don't feel only my professor will say something, then only I can learn something. Historically, there are the brilliancy, and that doesn't require sometimes the guidance. They require the inspirations, motivations. To do something, only someone has to, only you trust someone and someone says that, yes, go ahead, go straight, you reach there. And they trust. That's why I say the liking, disliking. If you like a person, definitely the theory becomes easier for us. This is my realization. I can assure you, whatever I say, I have the practical knowledge, and I realize this from my end, as well as I have very good data of the people so far we met them, and that too also different races of the world, not only this race, and different professors of the world, how they think. So we try to enter into the brain of the next, that how they can think, why we can't think. Definitely there is some analogy. Sometimes differentiation comes, difficult to understand, but you try continuously, and if not 100%, you succeed up to certain level. These are the two. Let us go a little bit ahead of this. Later on, what happened after the Kannan, I am talking about only what the result inspired me. Okay, that only I am talking about today. So Kannan is done. After the Kannan, I noticed the Boyd and Wong result. Okay, Boyd and Wong, and what the Boyd and Wong has done, that here this Tx Ty is less than or equals to He replaced this by a function, means force. Function is nothing but a, in a computational language, is called a force. Applying the force and making the distance, okay. You mainly, why you need alpha? That is very important to understand, especially those who are at a learning stage of Banach fixed point theorem. You need to show whether the sequence is monotonically decreasing or not, and later on whether the sequence is convergent or not. That's why you need alpha initially. Okay, fine, proving uniqueness is helping again, the same condition. But initially you need for these two causes. Why with this? So what they have done, and beautiful result published in Proceedings of American Mathematical Society, Boyd and Wong. They use this function. Of course, they also, in place of this, there was another result, okay, the same distance function t and t, this one. In place of phi, you can use something else also, because the metric you know very well that is greater than or equal to 0, right. So they use this also. So this is the Boyd and Wong's condition, and they are putting some conditions on phi, okay. They have chosen as a continuous function. Later on, this is weaken also, upper semi continuous functions in place of the continuity, and professor explained very well about this all semi continuity yesterday in particularly. You noticed or not, if you are not able to understand in the discussion session, once again you ask him in a very beautiful, and problem comes there only to understand actually we understand the process, understanding the process of showing the continuity, but how the function is really continuous, that is important. Like if I look into the same thing in a TV, look at the olden TVs, CRT monitors are there, later on LCD monitors are there, and now these days LED. What the difference makes? Printer also, typewriter 100% discrete, later on electronic typewriters, then dot matrix printers, then laser printers. See the difference? There is something, no? So what is the difference in LED and this LCDs? The pixel powers, the partition system, the number of particles or points are very, very close. That's the reason that if you have the points differently, how to draw a curve, you can see the curve looks like the joining of the segments. Can this joining of the segments make as a smooth curve? This is possible in computers now. Yes, such things can be made smooth, not only smooth, I can make it as continuous also. These are the intuitions you have to understand, and in research intuitions play a lot of role, vital roles. Be confident, use your intuitions, and don't discourage yourself. Someone if discouraged, you take in a positive manner. Okay, he says that I can't do, I can't understand. Because I understood very well that to convince myself, even professor is very close to me, you are also very close to me, if he tries to explain me some concepts, he can explain, but how do I understand? Unless I say myself that yes, you understand this, you cannot understand. So you try to do not motivate. You motivate, even the negative thoughts comes or some negative power come against you to demotivate you. This is possible because this is the world full of sins. Now this is because that's why we call it as a Kali Yuga. You will find good number. Out of the 100, hardly you find one, hardly you find one to whom you can say, yes, I can understand. You can't. So you have to trust yourself. So this one, so this is also the part of when I was working. Later one result actually in between inspired me, and let me write that inequality and I will explain you how this. So this is one inequality everyone is using, those who talk about the fixed point theory. Okay. The T is a mapping from capital X to capital X, any space you can pick. I am not bounding this the space. So you have X, Y, Tx and Ty. Here you have X and you have here, I can say, image here, this is the transformation, X here and this is the Ex. So these are the points you have, 2 points in the domain and the other 2 points are in the codomain. Based on these 2 points, they picked only 4. Banach picked 4 and Kannan. If you just analyze this, use the analytical method. So Kannan picked 4, right? So let me say like this. After Kannan, at the time of Kannan, only few people were working on the area of the functional analysis, particularly fixed point theory. But the majority of the people, they were working on summability, especially the Indian scenario as well as the American context. Europeans mostly, they are, even today also, they are more interested on the geometry side because of the schools. Schools means thought actually. We call it as school. School means a center of learning in when you talk about the synonym, but it's a thought. And they have some thought, like there are some institutions, they are famous for some reason. Like professor is from IIT Madras, it is famous for one of the some branches. This is because why you why you want to get admission into this institution, because I want this subject. Like that, some thought is there for each school, and each school is very concrete in their own way. So here you have this, and you can suppose if you generalize in place of 1 to 2, the question comes, the generalization has come after the Kannan, around after 1969, because as yesterday Professor Brinde was also telling, Professor Veeramani also told, mathematical reviews, and as he said, I was not knowing that part, that a person from Chandrabled, he left Germany and went to US. There are many, like one of my collaborator, Gerhard Young. I say Zhang, but he is not Zhang, he is Young, Gerhard Young. So he also from German, but settled in Bradley in City, Illinois. So such I have also no idea. And mathematical reviews, definitely our teacher used to say, for 6 months you go and spend to search the reviews. I think you have also written. I have also written. She has, Manjusha Kulkarni madam also written. So we used to write the diaries and small pocket type, small tickets are there. It is written on those tickets that what the results. So we used to write the abstract of such results on these pockets. And suppose 100 results we have written the similarity. Suppose I want to work, professor says that okay, you go and work on the commutativity part, or you work on the area of the Brouwer fixed points. So I will go and search only the results related to Brouwer, and I will write the results or main results. I will read everything. Apart from that, I will write the gist of that result on that particular paper. So like that, suppose I have written 100, I will place all the 100 on my table to visualize at a time. Forgetfulness is very easy, and in research, researchers are mostly it comes automatically, forgetfulness after some time. Those who do not forget, they become genius, and that is very rare. And the world is not running because of genius, world is running because of the average people, not because of the genius. Genius, yes, they are genius. We are going to derive their results, that's fine. So after 1969, that is K. Goebel, now he is no more. So some people started generalizing this, the mappings, generalization of mappings after 1969. I have seen some papers, that's why I can say this is available in the mathematical reviews. But their generalization is in this manner, This is the generalization. Okay. So you can think why this kind of generalization? See, this question has to come. Actually, whatever I speak today, at the age of 22, 23, I have joined my PhD, and what I was thinking, same I am trying to reflect today in front of you. So this is what, but there is a similarity. You follow strictly Banach proof, strictly only you need to define these two mappings using such Picard's iteration, one for even, another for odd. When you define, so you have the almost every part, you can reach till the end, that you have a Cauchy sequence, and because of the Cauchy sequence, the completeness of the space compel the sequence to be convergent. Okay. First we try to understand normally how to prove this completeness, and once we have the idea, then we say that make it compulsion to converge, this we say. So you get it, you get for one fixed point, you get for the other one also as a fixed point. When you get the other one also fixed point, so it comes like this. If one curve is like this and another curve is like this, then in such cases this intersecting point, this started in 1969 onwards, common fixed points. So far we are only talking about the fixed points, common fixed points. Once again the question comes, whether the common fixed points are unique or not. Maybe, may not. There are many non-unique common fixed points. Non-unique theorems are there. This Chirk has done lot of work. He used some minimization conditions also. And in Chirk's condition you will find maximum. So this is one way of introducing the map. What could be the another way? Anyone can? This is the one way I said. What could be the another way? At least I want to know from the MSc students at least. What could we think? I use T1, T2 in the left hand side first. Of course, they are different curves. Any intuition you are getting? Any one of you? So what could be on the right side? You just simply think what to do. So in place of T, let me say this is F, this is also F, this is G, and this is G. These are two different maps. So actually G zone is famous for this inequality. I don't know why the people not noticed earlier. I also did the same mistake what the others have done. I also followed the pattern. Later when I realized, immediate I have given a corrigendum and I included K. Goebel. K. Goebel already did introduce this in 1969, the same result, same inequality. But he was not able to prove, or maybe he left not interested to obtain a fixed point. He left with this condition, fx equals to gx, and we can call it as a coincident points. This is the coincident point. But the famous is Z. Jung, who has used, who generalized the condition of, sir.
Change the pink color is not there.
Okay, black is okay? Okay. This reflecting, I think. Okay. Now is okay?
Yeah.
Fx, Fy less than or equals to alpha times Gx, Gy. Okay, fine. This inequality I have now. Now what to do? The next. The next question is, if we follow the pattern of Banach, what the Banach has done, if I follow in that pattern, then definitely the next comes the iteration. How to define the iteration? So for such iteration, we require, this is first condition. So we require another condition, that is the containment of the ranges. This condition assumed in Jung's result for the construction of the sequence. You cannot just take it granted like can define the sequence using the Banach or Picard's iteration. So now you have the sequence also, you have the condition also. So up to what level we can reach when we have a sequence and one inequality? We can through up to Cauchy. Unless we exercise, we don't know, but up to Cauchy we can reach, I think. This intuition it says that we can reach up to Cauchy. Space is complete. So now the sequence is a convergent sequence. So if I say how the construction of the sequence is here, if I say let x naught is an arbitrary point of x, so definitely my point is like this, f of x naught. So this f of x naught is a point of fx. When f of x naught is a point of fx, so this